going to solve a trigonometric equation. So we're going to talk about how you can solve a trigonometric equation that looks something like, let me get here, 6 sine theta is equal to 3 sine theta plus 2. I tried to do a fancy theta there. Don't know if I pulled it off. Don't think I did, but if I keep trying, one day I will. And we're looking for values between 0 and 2 pi. So we're not looking for anything, any degrees or any radians outside of, or this is radians, so any radians outside of 2 pi. All right, so looking at this, I think I want to try to get the sines or the thetas on one side of my equation and the values on the other. So I'm going to subtract 3 sine theta here, sine theta here. 6 minus 3 gives me 3 sine theta. And this is going to equal 2. Now I need to isolate the sine of theta, so I'm going to divide by 3. And now I have sine of theta equals 2/3. Well, that doesn't tell me too much because it could be basically anything. So what I'm going to do is I'm going to take the inverse of each side. And I always, each video, I always choose this color blue. And I always say, why do I choose this color blue? Because it's a little bit harder to see. So I'm sorry if you cannot see that color blue, but I'm using the inverse sign and I'm taking the inverse sign of each side. Inverses undo the actual function, so we're left with just theta is equal to this inverse sine of 2/3. Well, the inverse sine, I'm going to have to import this into a calculator to get my radians. I got to make sure that the mode is in radians and not degrees. So theta here is going to roughly equal 0.73, because remember when we're working with radians, we're working with pi. Pi is an irrational number. Irrational numbers go on forever, and therefore this will go on forever. So we're just going to truncate it down to 2 decimal places. All right, so if you reflect on the terminal side of an angle with a measure of 0.73 radians across the y-axis, the angle you're looking at of sine 2/3, because again, we're looking at 0 to 2 pi. Sine is your y values, so this one, quadrant 1 will have a positive, quadrant 2 will have a positive sine. So we're looking at it going on this side as well. So if we reflect it with the terminal side angle of measure of 0.073 radians across the y-axis, the angle we'll also have for sine will be this pi, because we're here at pi, minus the reference angle, which is 0.73. So pi minus 0.73. And these are the only 2 quadrants that sine is positive in, so I don't have to worry about quadrants 3 or 4. Because again, sine refers to the y value in quadrants 3 and 4 are negative. So looking at this, we get approximately 2.41. So two possibilities that theta could be is theta could be roughly 0.73 radians and 2.41 radians. All right, so approximations in this example, we did 2 decimal places. If you are going up to upper level maths like AP Calc, you want to use 3 decimal places. But again, here are 2 solutions for theta where the left side of the equation equals the right side of the equation. All right, guys, so here is the end of this problem. It was pretty quick. If you have any questions, always feel free to ask. Always remember to look at your quadrants, knowing that sine refers to the y values, cosine refers to the x. So if you're looking at positive or negatives, note where that happens for x and y. And I will catch